Welcome back, anatomy students. Today we are going to take on the end of, hopefully, will be the end of the special senses unit. And this is going to be video lesson 3B. And we're going to talk about balance, equilibrium balance, and summarized with the homeostatic imbalances of the special senses unit. All right, so let's go ahead and get started. All right, let's talk about your equilibrium. Equilibrium is another function of the inner ear controlled by the vestibular apparatus. The components of that would be the saccule and the utricle of the vestibule and the three semicircular canals. So notice this area is all grayed out. Okay, this is for hearing, so we're not talking about this area of the inner ear. We're now moved over to this area here. So the saccule is right here. So this is the stapes. This is the last of those three ossicles, those three bones, and it's attached right here. So what we're missing is the other three, the malleus and the incus, which would be, about this area. So that means the saccule is going to contain the oval window. So here's your stapes right here, and then the utricle is right here. And these are going to be your areas of balance. And so then these are all your semicircular canals. So they are going to help us in balance. They're going to help us with static equilibrium and dynamic equilibrium. So what's the difference? Static equilibrium refers to the state of balance relative to the force of gravity. So this lets you know what's up and what's down. Whether you are sitting still, whether you're moving, no matter what, it just tells you which way is up and which way is down. So this basically lets you know if you're sitting there in the chair and you start to lean forward, your body tells you, hey, we're leaning forward, straighten back up. This is one of those things that subconscious action when you guys fall asleep in class and your head starts to bob. And then while you're sleeping and your head leans forward, your ear says, hey, we're falling forward, and you snap up real fast. And then you look around to see if anybody, mostly me, caught you doing that. That's what's happening there. And then dynamic equilibrium involves the maintenance of balance during sudden movements. So this basically will let you know when you're moving, it helps you keep your balance while you are moving forward, backward. When you make quick adjustments to your forward movements, if you're walking and someone's coming at you in the hallway and you have to dodge them, you make a sudden move. This is where your ear will help you maintain balance under those conditions. Static equilibrium is controlled by the sensory hairs within the macula of the utricle and the saccule. So here are the hairs, okay? And this is a gel, otolithic membrane. It's kind of gelatinous, so it will respond the same way Jello would respond. And these otoliths are denser, are heavier. So when you tip forward, these otoliths will respond in falling with gravity, which causes this Jello. Imagine if you had a plate of a Jello mold and you tipped it forward, the Jello would sag to slide off of the plate. Well, this jelly, this otolithic membrane, will do the same thing. And when it starts to sag forward, pulled by gravity of the otoliths, then these hairs will bend. As soon as these hairs bend in response to this membrane bending, then they send electrical stimulus to your brain that says, hey, we're leaning forward, straighten back up, or Mr. Grippa is going to see that we're falling asleep in class. So here's that demonstration. You see his head is straight up. His otolithic membrane is nice and level. His hairs are pointing straight forward. His head dips forward, and you can see this otolithic membrane starts to lean forward, which bends the hairs, and that sends signals to the brain that says, hey, we're leaning forward. So the otolithic membrane, studded with the dense calcium carbonate crystals, responds to gravity when head position is changed. Dynamic equilibrium is controlled by the sensory hairs within the ampulla of the semicircular canals, which is here, here, and here. So this area gives us static equilibrium. These give us dynamic equilibrium. Within each ampulla is a small elevation called the crista. Each crista contains hair cells and supporting cells covered by gelatinous material called the cupula. With movement, the endolymph within the ampulla lags behind moving the cupula, causing a difference in inertial forces. The hair bundle of the cupula bends and nerve impulses are generated. So they kind of act in the opposite manner of your otoliths and your otolithic membrane in dynamic equilibrium. So when you move forward, this will bend in the opposite direction due to inertia. Newton's laws, a body at rest tends to stay at rest. So this bending here would mean, since it's bending this way, that means that this part of your head or your body is moving this way. Oops, sorry. So it's moving this way, which causes the otolith to bend that way. The endolymph to bend that way. And that, of course, will send signals to the brain that says, hey, we're moving this way. So that is how it helps you maintain your balance. All right, let's talk about homeostatic imbalances. A cataract. A cataract is an opaque defect in the cornea or lens of the eye. Most cataracts are in lenses. And as you get older, you may run into complications with your eyes where your lens or your cornea becomes cloudy. You have a hard time seeing through it, and that's called a cataract. And what they do now, my mom has recently had cataract surgery, and what they do now is they open your eye, they make an incision in the cornea, and they fold it back, and then they go in and they remove the lens. Now here's the crazy part. My mom has worn glasses for almost her whole life. I think she got her glasses when she was in elementary school. So she has had glasses or contact lenses for almost her entire life. And when she got cataracts, they went in, they looked at her eyeglass prescription that she needed for her eyes, and they made her artificial lenses that corrected for her particular visual impairity. And then they put the new lenses in her eye, reattached the cornea, and her vision was fixed. So not only did they get rid of the cataracts, but they also got rid of whatever visual problems she had. So now all she needs is reading glasses because her lens, since it's artificial, it does not flex very well. And as we talked about earlier, when you get older, your lens loses its elasticity and you can't see very well up close. So you need reading glasses, as I do. Anything within a foot of my face, and I can't focus on it. But I can see at distance. So my mom, who's never been able to see at distance after her cataract surgery, is now able to see at long distance without any corrective lenses, because her new lenses have been made to take care of that. Conjunctivitis, you may also know it as pink eye, is an inflammation of the conjunctival membrane which covers part of the front of the eye. Conjunctivitis is caused most frequently by viral infections such as pink eye or an allergy. It can also result from bacterial infections and many other irritants. So it's not always the same thing that gives you pink eye. Another homeostatic imbalance is called age-related macular degeneration. This results in a loss of vision in the center of the visual field, the macula. So it's not the lens that's getting cloudy, it's the actual part of your retina that's having problems because of damage. So the retina has been, maybe overexposure to UV radiation. So, for those of you who go to the the tanning beds, and they give you those little goggles to wear, that's why, because UV radiation will destroy your retina. So make sure you're wearing those goggles. It's a major cause of the visual impairment in older adults, anyone over the age of 50. It can become impossible to recognize faces since it's always the macula is the center of your retina. and that's always where you look, and wherever your visual center is, and when you go to focus on someone, you look directly at their face, and that's where you can't see. That's where your vision is the worst. And so as you go to look directly at someone, you can't see their face, and you have a difficult time recognizing their face. So to be able to see them better, you have to look next to their face, and then that will help you visualize who it is you are actually seeing out there. Another imbalance is called myringitis. This is an inflammation of the eardrum. Infections of the middle ear cavity called otis media are common in children between 6 months to 5 years, and usually presents with a crying child and a TM, or tympanic membrane, aka eardrum, viewed through a tool called an otoscope that looks angry, red, and bulging. Angry. I don't know what an angry eardrum looks like, but I guess that's why I'm not a doctor and just a simple anatomy teacher. Another homeostatic imbalance with the ear is called otitis externa, commonly called swimmer's ear. It is a dermatitis of the epithelium of the outer ear, or infection of the membrane. Chlorine, water, and earplugs associated with swimming can result in an irritated, inflamed tissue of the outer ear and ear canal. And so another example would be the distended eardrum caused by otitis media. And that is so they opened this individual's ear, and then you can see the eardrum is being pushed out of that ear canal. And I don't know about you, but that does not look very comfortable at all. All right, that is the end. Okay, that's going to take us to the very end of our special senses unit. So we know the drill. Go ahead and head on over to Schoology, find the exit slip for Special Senses Lesson 3B, and answer those questions. Go ahead and hit submit and send that on to me. So nice work. That concludes Special Senses. So hopefully we've been staying up to date and studying and getting ready for that test. All right, we'll talk to you later.